they don't have a 20M. 20M is a bit small and normally not very commonly available because nobody buy. Nobody buy. So the manufacturing also don't manufacture. Normally in the market, people minimum go for RCD. I think minimum also is around 40, 30, 30, 40, 30 and above. 30 and 40 and
the catalog.
Yeah,
they provided 30
and you cannot find. So if you cannot find, what you put?
Maybe I just make all the lighting together.
Okay.
Okay,
one thing most important is when we design something, we have to design something that is available. We cannot design something that we assume. Okay, let's say I'm a design engineer. I design something, then the contractor come back and say, hey, boss, I cannot find this part. Never mind, you go and think what to buy. You go and buy from China or go to Africa and buy. I don't care. But if like that, then it will be difficult because people, when they look at this, they will cost the price very high. Normally, something uncommon, people will price very high. Then your design, when it come out, the owner look at it. Last time my consultant designed for me a library, only cost me this much. But now your design cost me double the price. Then he will find out what is the problem. So design something that you have to always refer to catalog. What is more common, use that. Okay. So I think the RCD for lighting, normally in the market we use 100 milliamp. 100 milliamp. Only the switch socket outlet we use 30 milliamp. You know the reason why 30 milliamp or switch socket outlet? Because
it prevents the short circuit.
Correct. Because 50 milliamp can kill a person instantly. So actually the Suruhanjaya Tenaga has set a law. All the switch socket outlet, you need to be protected by 30 milliamp RCD because it is lower than 50 milliamp. Because 50 milliamp can kill a person really. So they make it lower so that when any leakage, let's say you plug a handheld equipment, suddenly it leaks and shorted you. Because of leakage current, the RCD trip within instant or within second, then it protect your life. So that's the reason why you need 30 milliamp. But for lighting, normally in any installation except household, normally only the well-trained technician or the competent personnel can go up there and replace the bulb or go and replace the ballast or touch the ballast. Under Suruhanjaya Tenaga, you cannot touch the light unless you are being trained as a wireman, either you are wireman Fasa 1 or Fasa 2 or Fasa 3 or Fasa 4. Only wireman can touch live connection. So normal people cannot, unless your own household. But there's a reason why for lighting, usually in order to prevent frequent tripping, we will set it higher to 100 milliamp. Means it's something that normal general public cannot touch. So you are not going to put your computer and plug to the lighting load, not possible. So it's something that you will not touch. The danger is not there. But why we set 100 milliamp, which is above 50 milliamp? Because lighting, a lot of times they got flickering. So when you consume so many ballast and all the ballast also consuming power at the same time, there is some required distort current into your electrical system. So when you set it too sensitive, 30 milliamp, you worry that the RCD will pick it up and trip. So you don't want it to be frequent tripping. So we set it to 100 milliamp. Okay, that is the reason behind. All right. Fine.
Then for these computers, we will be using the 6 mm square copper wire because it draws about 40 amperes. And then the MCB rating will be 40 amperes and the RCD rating will be 40 amperes.
But how do you ensure 6 mm squared is sufficient? Did you refer to any table?
Yeah, from the IE 60 edition.
Very good. Table
4.28, 18, because I forget the name.
Okay,
it's around there.
So normally you have to be careful. That's the reason why just now I emphasize single core, 4 core. When you read the table, single core is different reading. 4 4 different readings. They jump out before different readings. Copper different reading, aluminium different reading.
Include the connection.
Correct. So when you connect in single phase, it's different reading. When you connect in 3 phase, different reading. So you know how to read?
Just not that very familiar.
Okay.
Just assuming.
Okay, never mind. Next time I can guide you, but you need to know how to read in order to get the right data. Or else you plug in the wrong data, wrong input equals to wrong output. So your design won't be right.
Do you teach them how to read data, Roy? Table.
There are two ways of knowledge. One is you know how to do, one is you know where to do.
That's the book. Okay, I just take one quick moment to just share with them. Because I use this almost daily. Almost daily. When you as an electrical engineer, you use this a lot. Every day you also refer to it. Okay, you must know how to read it. Okay. Okay. Which cable? Okay. So you are single core, correct? You are using PVC insulated, correct? Non-armored, correct? You must know how to differentiate. Armored and non-armored different cable also. There are many different cable here. So this is correct, means your cable, you are sizing based on it, you refer this data. So now you need to know okay. Now you need to know the installation method. The installation method, you got reference method 4, 3, all these. You can refer from here. What is the installation method? This from here. Okay. So normally for this lighting circuit, normally is in the enclosed conduit. It can be enclosed in concrete. It can be some certain area above the ceiling is not enclosed in concrete. So to play safe, I will assume enclosed in concrete. Okay. So enclosed in concrete. Which one? This method. The enclosed in concrete on a wall or in trunking. So lighting on a wall or in trunking. Okay. Lighting on. Okay, fine. So this is a single phase. Okay, fine. Okay. 6 mm is oh wrong. This cable is inside your own switchboard. Inside your own DB, correct? Means from your main incoming 6 mm squared go to your lighting. Correct? 6 mm squared will be there. Cannot be. That one should be 2.5.
2.5. No,
Why
this
not?
is for the switch for the
Switch okay. Switch okay outlet is 2.5, correct? But your lighting just now you are 6 mm squared is for what?
for here, I think.
Okay. 6 mm. Yeah. But the whole thing is inside 1 dB, right?
Yeah. This whole thing inside 1 dB.
So in the actual case is looping inside the same dB. Very short distance only. So it cannot be enclosed in the conduit.
Oh, okay.
Okay. But this one we can actually because there is no exactly the right installation method, we can assume we need to assume reference method 4 in thermally insulating wall because of heat everything you contain inside DB. The DB is very small, but you got so many wires inside. So the wire dissipate heat. Your DB is actually quite warm inside. So when you are running a cable inside a warm cubicle, you have to assume it's thermally. So your means the heat dissipation is no good. So you have to go back in reference method 4. 30 with 30. Yes. Do you know that the heat factor actually can bring down your current carrying capacity of copper? Okay. So yeah. Okay. So if let's say the same size of cable 6 mm squared, if I lay this cable in a free air outside the building, free air, which is very much ventilated by air, the current carrying capacity is much better. You can almost reaching the specified requirement. But if I put it inside a very cramped area like above the ceiling, or maybe I put it inside the wall, with a lot of cabling inside, the current carrying carrying capacity will drop, will significantly drop. So there's one, there's one table here that's talking about temperature. Yeah, no, it's talking about correction factor about ambient temperature. Ambient temperature. You have to give a derating factor already. Okay. Or else you can everything based on perfect condition. But when you install at the site, you will find that your cable overheated. And then sometimes the performance is not as good and certain things will intermittently trip. Because a lot of times things intermittently trip for the RCD is because the whole system, the cable is heated up. When the cable is heated up, it brings the heat back to your DB, and your DB, there is a hotspot due to whatever thing. It can be a loose termination or whatsoever. So it will cause your RCD to trip intermittently. And this kind of problem not easy to solve on, because you don't know what exactly the problem. But because of the design, you have to design in the proper way. So this one actually already teaches all the correction factors. You must know how to apply it. They tell you the ambient temperature. Yeah, the temperature goes up, your current carrying capacity actually is, you only have to multiply. Let's say for instance, based on here, you say is 41 amp. But you have to multiply, let's say this one is a hotter. Let's say for 35 degrees Celsius, you have to only apply 0.97. So the actual current is dropped a bit. Then you have to see the current, is it still fulfilled? If you still fulfill, you still can use 6 amps. If cannot fulfill, you have to use one size higher. One size higher. Okay. You must know how to read this table.
So is it safe? The design, is it safe?
I think rule of thumb, I look at it, definitely 6 is more enough. It's more enough.
So they have over design or what?
Oh, no, it's not over design, but I'm actually have to guide them to how to really make use of this table. It means you must know how to interpret from this table correctly.
Okay.
Then to another DBs, the second DBs will be just served for this DB is just served for the switch to outlet.
Yeah, you have to understand. This cable and this cable is inside the DB. Yeah, very short only. Okay, continue.
Yeah, it is just served for the switch socket outlet. There will be and the air conditioner system. And then there will be for the air conditioner, the total maximum load will be 67.8 kilowatt, and the current load will be about 120. So I'm using the CCV rate will be 125. And then the D5 square copper wire will be using. And then the air conditioners is draw about 61.6 kilowatt. The estimated current draw will be in 120 amperes, and the lining system just about 3005, and then the 6 ampere will be draw. In this
okay, just something to look at it. I just look at 35 mm square may not be enough
for the
125 amp. For the 125, you see, in IEEE wiring regulation, it already mentioned very clearly. You size the breaker first. After that, you size the cable based on the maximum current rating of the breaker. Because you have to assume this breaker, if you not treat up to that amp, this cable will actually melt or short circuit or cause fire. So you size cable, you must size according to the current rating of the breaker, not size based on your maximum demand. Definitely not. But you size your breaker, you can size based on your maximum demand with some additional spare load. Okay, means you know your maximum demand is 100 amp, but I may need to cater for a little bit spare load, normally 25%. Let's say 25%. So it's going to be 125 amp. So 125 amp, I size my breaker, but when I size my cable, I have to size exactly 125 or even more than 125. Cannot be lower. Because why? If it's lower, the breaker will not trip at 124. the breaker will not trip at 125 instantly. If you look at the IDNT curve or whatever the tripping curve, exactly at 125 M, the breaker maybe take few hours to trip.
Yep.
But at that time, maybe your cable melted already. So your cable have to size minimum 125 or even more. Cannot be lower. So this is the IEE wiring regulation. You have to, this is very important. This is very important. Okay. So I look at the 35, I think, just look at the M rating, I think it's low. Okay.
Under specs.
Undersize again.
Yeah, under specs.
It's okay, no more. Anyway, when you make mistake, only you learn. If you everything perfect, you won't learn. You won't learn. But from here, after you learn, next exercise you will become better. But you must know how to read the table. You must know how to apply the correction factor. Okay.
And then this DB just supply for the switch socket outlet.
Fine.
Yep. They'll be the same for the RCD will be just about.
Okay. Another thing to switch socket outlet, you assume 70% is used.
Yeah.
I think it's at the high side.
High side.
High side. Because this is a library.
Yep.
To be frank, the library, I think you don't have much computer inside, right?
Got. There are about 60 computers using. And then and then 2 photostat machine.
Okay.
Yeah.
60 computers.
Yeah. This one is.
And the students bring their own computer.
Yeah.
Bring their own computer.
Yeah.
So
They
will
bring
plug
their
their
own. Yeah. They will plug them down.
Okay. Okay. So your assumption for socket outlet is how many watt per socket outlet?
Per socket outlet 1,500.
1,500 watt per socket outlet.
Yeah.
Too high.
Too high.
Too high. Generally, in our practice, in industry practice, 250 watt per socket outlet. Okay. Computer actually, when you plug to a PC, how many watt is the switch plus monitor? Let's say I do assume laptop, 500 watt.
Yeah. Maybe even higher.
500 watt. Okay. 500 watt for PC. Okay. I don't think it's 500 watt is correct for PC. I don't think so.
Because include the monitor.
Yes. Monitor is
about
80-20 watt. But the CPU cannot be using so much.
CPU is so much because you calculate calculate the RAM using CPU using all the things add up. It's about 500 watts. Yeah.
Do you actually measure the current when the computer is? I think it cannot be 500 watts.
Because we cannot measure it in the laboratory.
I think this one we need to explore a bit, but I think 500 watt is really too high.
Okay.
Really too high.
So maybe
for a computer.
Okay.
I have to assume
Are you
PC.
guiding a PC or a notebook?
No, let's even assume a PC because
Computer supply.
PC will be safer if you design PC. Now a lot of people use notebook. Notebook definitely not work. But let's assume PC. But I'm quite sure it cannot be 500 watt.
Okay.
I'm very sure it cannot be 500 watt.
No, they just put the power supply.
Correct. You know rule of thumb.
But that one is maximum, right?
Correct. You know rule of thumb. 500 watt is near to 1 horsepower. You know our aircon. If it's running 9,000 BTU, it's only about 2 amp to 3 amp running load for aircon. Which is, if yours is 500 watt, let's say single phase, talking about 2 amp cannot be. Straight away, I mean from the logic I know is not right already. Not right already. Not right.
So make changes,
In our normal design, we assume one socket outlet is 250 watt. Already enough, and we have designed so many, and never have everyone. So 500 watt cannot be right.
But in their design, right, okay, maybe one circuit switch socket outlet plug is connected out again.
Or extension.
Yeah, they will extend it out.
Okay,
Actually,
fine.
maybe extension 4 or 5.
Okay,
Yeah.
even though 4 or 5, I think because when we design 250 watt, does not mean this socket cannot produce more than 250 watt. 250 watt is a good estimation.
Okay.
and you multiply the quantity of all the socket outlet with 250 watt, the total, let's say you have 100 socket outlet, I multiply 250 is going to be a big figure. If I assume 500 watt for the socket outlet, I multiply 100, the load is even higher. But at the end, everything will be go for very high load demand. Eventually your cable will be bigger, your DB will be bigger, your incoming will be bigger, everything bigger. But in the actual case, when you count the metering, is so much less. So your assumption is very far away, and you are over designed and wasting money. Wasting money. So oversized and so very importantly is when we assume load 250 watt, but this socket can deliver 13 amp. 13. Because this is the standard 13 amp socket outlet. So this switch socket outlet can give you 13 amp without any problem.
Because I assume that according to the use.
So if 13 amp multiply with 240, how many watt?
1500.
Yeah. 1500. Yeah, 1500.
Yeah.
Okay. Let's say 1500 is the maximum.
Yep.
Is the maximum. But 1500 can produce a lot of work already. But even though you have multiple computer connect to it, you will never reach 1500. Never reach. Never reach. You know 1500 divided by 240 is how many amp? Divide 240 how many amp? About 1, 2, 3, 4, 5, 6, 7. 6 to 7 amp. You know 6 to 7 amp is an acorn of 2 horsepower already. 2 horsepower acorn already. So I know definitely the assumption for a PC 500 watt is
too high.
not correct. You go back and check. I believe a normal PC will
220.
100. The most is about 100 watt
100.
100 or 100. The most is what. But you check back the spec. What you can do you go to the internet, check the PC, and then you go to Dell. The Dell catalog actually tell you what is the actual power consumption. Is there.
Okay.
And then from there you will know it's much less. Even one socket I connect a few also, it will never exceed 1000 watt. But from there, when you design, because switch socket outlet is very subjective, not like lighting. Lighting, when you on off. When you off, you off. But switch socket outlet, you don't know if people use it or you don't know people not use it. Sometimes people can use more, sometimes people can use less. So your diversity factor is very important. If your diversity factor is very high, eventually everything size very high. Your DB also very high. But by looking at library, do you conduct any survey at peak time? How many people is utilizing the socket outlet?
We can't, because don't have the time.
Okay.
Because during they have class, we also have class.
Okay. I will recommend you do it. Because why? A lot of time when we do design, when we're not sure, we normally go to the actual place to study how they operate the thing. Okay. Then from there we can know what is we call it load profile. Load profile. You have to draft out the load profile. Just now when you draw all these things, it's called load profile. But now you have to understand the load profile. The load profile, electrical load profile for using socket outlet in the library. And I believe without looking at the thing, during the very peak time when everybody plug at the socket outlet, it will not run that high as 70%. And when you assume 1500 watt, multiply 77 and multiply by 0.7, 80 kilowatt is very big. 80 kilowatt is 100 over M. 100 over M is very big. And what is the total power? What is the circuit breaker rating, the main circuit breaker rating for the library, the incoming?
For the main, for the
main. No, for the main they come into the library before it branch out to Acorn, lighting and all this. Not really sure. Incoming is how big?
Incoming. The 60 is MCCB for each.
Oh, 60 MCCB for each.
Yeah.
So you got Acorn, power, and lighting. Yeah, 3. Okay, even 60 for 3, 60 times 3 is 180. Your just a socket outlet of itself already take 112. It's not logic. Imagine your biggest load is aircon, not power point. Actually, to me, when I do this, normally I would assume 30%. 30%, not 70%. But 30% is based on assumption. The best is do a
Survey.
picture survey.
Okay, in August, do a survey.
Do a survey. This is going to be an exercise. That is what we call project. You go there, survey how many people using the socket outlet with how many computers during a very peak time. Once you get that, I even allow some safety factor. Means we can even multiply by 1.3. Additional 30% on top of your peak is very safe already. Even that, when you calculate back, is still far lower than this. I'm very sure. Far lower than this. Okay, continue.
And this is just for the 28 kilowatt air conditioner. And then the total load that will be draw out is about 235 kW, and the maximum current is 410. The MCCD I use is 400 because the
Existing is 60 only. Existing.
yeah,
60 only.
yeah.
But now your aircon, you
No, because the aircon is separately. They maybe put at another part, not inside the library.
okay.
Inside the library, just supporting the wall mounted and the ceiling cassette.
Okay. So 60.
Yeah.
But the other side, the total is how much? Do you know?
No.
Now you are calculating based on total.
Yeah,
Based on total. Do you know the additional compared to the 60? How many more aircon unit extra from there? Do you know?
how many inside the 60 here?
Okay. How many is supplied by the 60 ampere first? How many aircon unit? Let's say count for
supply about
11.
13.
Okay, fine.
They supply
13. So 13 contribute about 60 lah. Let's say lah, maximum 60. If it won't be 60, I think mostly the running it only 30 lah. Based on that. Okay. Then the one that not supplied by 60, how many unit?
Not supplied.
Not under the 60 M one. How many unit?
This is about 8 unit.
8 unit. Okay. And this 8 unit, the aircon size is about the same. More or less the same.
Is
Bigger.
Because bigger a lot. This is 28 kilowatt. That one just about 11K is the most biggest.
Okay. So this is the bigger aircon.
Yeah, biggest.
Okay, this is the bigger aircon. Okay, fine. So alright, you can continue.
Yeah. The MCCB used is about 400 amperes, and the copper cable they use is about 185 millimeter square.
Maybe.
Yeah.
Very good. I straight away I look at it, your 400 M is not so correct. Without even looking at the thing. 400 M is something really oversized.
But if we really need to do the assumption for
28 kilowatt
because
the
the maximum current is throughout is already 410.
do you refer to catalog 28 kilowatt aircon? What kind of aircon is that? Very big.
Because they are just like the ceiling cassette.
Ceiling cassette you mean? Like ducted. Okay. In terms of ducted means centralized.
Yeah.
If we centralize using chiller, air chiller, no chiller.
They use fan coil.
Okay, the one is called, okay, this one is it the package unit or the split? So indoor and outdoor separate lah. Okay, it's a bigger outdoor unit lah. Maybe the one is could be
the biggest.
Okay. By right, I'm thinking our system should be even more energy saving. 28 kilowatt, I don't know where you get it from. Is
Because it's based on the summary that I get
on. Let me just make a very rough calculation. 28 kilowatt, one unit, 28 kilowatt times 1.64 equals to one aircon unit already consume 45 M. That's what cannot be. When you multiply total, how many units? 8 units.